guys, I just wanted to shoot one quick alternative video for those students who are working better with larger multiples of 10 instead of staying under, with multiples of 10 under 100. So this will work if you go to worksheet problem number 3. We still have the 9,478 divided by 46. And we're still going to use an area model. So we would still have our box. And we would still be dividing into 4 boxes because our number is 4 digits. And we'll still be breaking down by place value. So 9,478 divided by 46. Now, in the standard area model, we stayed with numbers that were multiples of 10, but they were less than 100. But in this alternative, for students who are working with larger numbers of multiples of 10, then this is a little bit different way that they can do this. Now, we know that if we, that 46, if we multiply 46 times 100, okay, if we use a 100, in the other version you couldn't go above, you couldn't use 100 or above. But in this version, you can go ahead. If you're working with larger multiples of 10 easily, then we can go ahead and use 100. So we would have 4,600, because 100 times 46 is 4,600, and then we would subtract. So we have 0 minus 0 is 0. 0 minus 0 is 0. Here we would have to borrow. So 10 minus 6 is 4. 8 minus 4 is 4. And just like the other model, we carry this over and add it to what we already had over here. So now we would have 0 plus 0 is 0. 0 plus 0 is 0. 4 plus 4 is 8. And nothing plus 4 is 4,800. Well, since we know that we just did this one times 100 and it gave us 4,600, and that's less than 4,800, then we can go ahead and we can use 100 again. And then if we multiply that, we again get 4,600. And if we subtract, we get 0, 0, 2, and then 0. So just like the other model, we bring that on over and add it to what was already over here. So now over here we have 270. Well, now we look and we say, well, 46 won't go into 270 any kind of multiples of 10, will it? No. So here we would have our 0, and 0 times 46 is 0. And we subtract, and we would still have 270. And just like the other model, it comes on over and adds to what we already had over here. So now we have 278. Okay, well, 46, again, it won't go into any multiple of 10, will it? Because if I did 46 times 10, I would get 460, and that's way too much. So we're on the last box, so this is where if it won't be with a multiple of 10, you have to start whittling away at it. Well, I know that if I did it times 10, it would be 460, and that's almost twice as much. So I'm gonna try a 6. I'm gonna go down by about half as much as it would be. So I'm gonna try a 6. And I would just go over here to the side and do my math. 46 times 6. 6 times 6 is 36. Carry my 3. 6 times 4 is 24. Plus 3 is 27. So, well, that works, doesn't it? That's going to be perfect. So 6 times 46 we said was 276. And when we subtract, we're left with a 2. Okay, well, I don't have any more boxes left. The number I came out with is less than my divisor, so I know that that's just my remainder, a remainder of 2. And then to get how many whole times in my quotient, I add these together. So I would have 100 plus 100 is 200, plus 0 is still 200, plus 6 is 206. So just like when we were working with the standard model where you had to use multiples of 10 that were less than 100, and again, that's for students who aren't working as well with multiples of 10 to work with the larger digits. But I just wanted to offer an alternative for students who were working more fluently with the larger multiples of 10. So you can you can go 100 to up even 200, 300, as long as you're more comfortable with working with those higher numbers of multiples of 10. You still get the same answer. It will go 206 whole times with the remainder of 2. It's just an alternative that I wanted to give those students, again, who are more fluent working with their multiples of 10. And if you don't feel comfortable working with the higher multiples of 10, then you can still use the ones that are less than 100. All right, thanks. Bye.